Government exam questions and solution in network theory. Discussion of previous year question paper. Question number 1. A supply voltage of 230 volt 50 hertz is fed to a residential building. What is the equation of instantaneous value? So the options are given like this. Solution. So the instantaneous value can be represented as V is equal to Vm sin omega t. And we know that the RMS value of voltage is equal to Vm by root 2. So from this equation, we can derive Vm equal to root 2 Vrms. So Vm equal to root 2 into the given value is 230. That gives you 325.27. So in the option B having 325.27. Similarly, omega equal to 2 pi f. So 2 pi into 50, it is 314.16. So V is equal to 325.27 sin 314.16 t. So the correct option is B, V equal to 325.27 sin 314.16 t. And question number 2. So two bulbs of 500 watt and 200 watt rated at 250 volt will have resistance ratio as. So these are the options given. So they ask the resistance ratio. So the resistance value for bulb 1 and bulb 2. So here the power rating is given. So we can write the power equation. So power equal to V square by R. So here voltage is specified. So we can write the equation in terms of voltage. P is equal to V square by R. In case current is specified means we can use the formula P is equal to I square R. So from this equation R is equal to V square by P. So for 500 watt bulb R1 equal to V square is 250 square divided by 500. Similarly for 200 watt R2 is equal to 250 square divided by 200. So keep this 250 square as it is so that it is easy for us to cancel that. And now in the question they ask the resistance ratio R1 by R2. So R1 by R2 250 square by 500 whole divided by 250 square by 500. So 250 square get cancelled and 200 goes to numerator and 500 comes to the denominator. So it becomes 200 by 500, that is equal to 2 by 5. So 2 is to 5 is the ratio. So the correct option is B, 2 is to 5. Question number 3. So if a power of 100 watt is being supplied across a potential difference of 200 volt, find the current flowing through the circuit. So these are the options given. So again we are considering the power equation. So power P is equal to V square by R. From there R is equal to V square by P. Easily we can find the R value. So V square 200 square divided by 100, that is 400 ohm. So we got the value of R. So now we can find the current by direct Ohm's law. I is equal to V by R. So 200 by 4, that gives you 0.5 ampere. The correct option is C, 0.5 ampere. In question number 4, calculate the total DC resistance of a 100 meter roll of 2.5 mm square copper wire. If a resistivity of copper is 1.72 into 10 power minus 8 ohm meter at 20 degrees Celsius. So these are the options given. Solution. So the resistance in terms of resistivity is R equal to rho L by A. Rho is resistivity of the material. So here the resistivity is given as 1.72 into 10 power minus 8 into the length is 100 meter. So 100 divided by area. Area is given in 2.5 mm square. So convert this mm square into meter. So it is 10 power minus 6. 10 power minus 6 we can cancel with this 10 power minus 8 and 100. 10 power minus 8 into 100 is 10 power minus 6. So 10 power minus 6, 10 power minus 6 get cancelled. So you will be getting 1.72 divided by 2.5. So that gives you 0.688 ohm. So the correct option is D, 0.688 ohm. So question number 5. So find R equivalent in the given circuit. So very simple problem. So by seeing this circuit, R equivalent from this side, then we have to start from the opposite side. So these two are in series, 52 and 28 are in series. So 52 plus 28, the circuit becomes like this. And by seeing this circuit, it is clear that 80 and 20 are in parallel. So parallel combination of 80 and 20. So 20 into 80 divided by 20 plus 80, that gives you 16 ohm. So the circuit is reduced like this. Now it is very clear all the three resistance are series. add all the three resistances, you will be getting 56 ohm. So the correct option is C, 56 ohm. Question number 6. A 9 volt battery supplies 1 milliamp current in a series circuit of 3 resistors R1, R2 and R3. If the voltage drop across R1, R2 and R3 are 1 volt, 2 volt and 6 volt respectively, find the values of R1, R2 and R3. So the voltage drop is given in the problem and the current is given. We are going to find the resistance value. Solution. So the voltage drop is given as I into R. So from there R is equal to V drop divided by I. So voltage drop for the first resistance R1 is 1 volt divided by I is 1 milliampere. So convert into ampere into 10 power minus 3. Bring this 10 power minus 3 to the numerator, it become 1 into 10 power 3. So that is 1 kilo ohm of resistance. For the second resistance, V drop 2 divided by I. So second resistance 2 volt drop. So 2 divided by 1 into 10 power minus 3, that gives you 2 kilo ohm of resistance. And resistance 3 is 6 volt drop. So 6 divided by this one, that gives you 6 kilo ohm of resistance. So the correct option is option A, R equal to 1 kilo ohm, R2 is 2 kilo ohm and R3 is 6 kilo ohm. Question number 7. Find current I in the given circuit. So very simple circuit, the three resistors are in series. Simply we can add all the three resistances and you will be getting the R equivalent as 800 ohm and voltage is given 12 volt. Direct Ohm's law, I is equal to V by R equivalent, that gives you 0.015 ampere. So the correct option is A, 0.015 ampere. Question number 8. Determine the voltage at the node A and node B in the given network. Observe the network carefully. So here node A and node B, at these two nodes we need to find the voltage. So these are the options given. Solution. So apply KCL at node A. So at node A, VA by 3. So we are applying KCL for this branch. VA by 3 plus VA minus VB divided by 2 and this one plus 3, that will be equal to 0, or else we can put equal to minus 3. So this is first equation. And apply KCL at node B. So node B, 3 amp is coming here and 1 amp is coming here. So VB minus VA divided by this 2 ohm, that is equal to 1 plus 3. So that gives you VB minus VA divided by 2 equal to 4. That is your second equation. Now equation 1 can be rewritten as VA by 3, taking minus out from the second term, it becomes VB minus VA divided by 2 plus 3 equal to 0. Since in the second equation VB minus VA divided by 2 is there, so we are converting the first equation in terms of VB minus VA divided by 2. So substituting second equation in the third equation, you will be getting VA by 3 minus 4 plus 3 is equal to 0. Simplifying this, you will be getting VA by 3 equal to 1 and VA is equal to 3 volt. So substituting VA equal to 3 in equation 2, and we can derive VB is equal to 11. So VA equal to 3 and VB equal to 11. So option D is correct answer. Question number 9. Determine the value of equal resistance across nodes A and B. These are the options specified. By observing the diagram, we can able to see this 2 ohm and 2 ohm are in parallel, and this 2 ohm and 2 ohm are in parallel. So the parallel combination of these two are 1 ohm. And here this 4 and 4 are in parallel, this 4 and 4 are in parallel. So the parallel combination is 2 ohm. So the circuit become like this, 1 ohm, 1 ohm, and here it is 2 ohm, 2 ohm, and the common is 3 ohm. And this is of the form a Wheatstone bridge, and it is a balanced Wheatstone bridge. So here in this branch 1 ohm, it is the same resistance, and here it is 2 ohms, same resistance. So it is a balanced Wheatstone bridge. In a balanced Wheatstone bridge, no current flows through the 3 ohm resistor. So the circuit is reduced like this, and we can easily calculate the resistance. So 1 ohm and 2 ohm are in series, it becomes 3 and 3 here, and now 3 ohm and 3 ohm are in parallel. So the parallel combination is 1.5 ohm. So the correct option is option A, 1.5 ohm. Question number 10. So find the voltage at node B in the given circuit, and these are the options given. So by seeing this diagram, at node B the voltage source is directly connected, and in the question they ask the voltage at node B. So directly we can take the answer from this diagram itself, and the minus terminal is connected to node B. So the option C is the correct answer. The voltage at node B is minus 12 volt.